Hello everyone, this is Adnan and welcome to Chemistry with Adnan. On this YouTube channel, I'm covering the entire syllabus of IGCSE Cambridge Chemistry and the course code is 0620. I also offer free lessons on my community on school.com with the name of High School Chemistry, and the link is given below in the description. You should check it out. So in this lesson, we will be covering 8.3. We are covering chapter 8, the periodic table. And today's topic is 8.3 Group 7 properties. So in our previous lesson, we talked about Group 1 in 8.2. So if you haven't watched that video, so you should check it out. There's a dedicated playlist where I have uploaded the entire syllabus of IGCSE Cambridge Chemistry, starting from States of Matter 1.1, Chapter 1, right? And there's another playlist where I have solved topic-wise questions from the past papers, right? And if you have any questions or if you need one-on-one lessons, so the information is given in the description, so you can reach out. So okay, so in this topic, we do not have any topic related to the supplement, section or extended syllabus. So all these topics will be assessed for core and extended students. So describe the group 7 halogens. So group 7 is halogens, and they include fluorine, chlorine, bromine, and iodine as diatomic non-metals with general general trends down the group limited to increasing density and decreasing reactivity, right? So now let me explain this. So they are diatomic molecules, yes, because they can, they have one electron in the outermost shell, and they form a covalent bond. So chlorine will exist as Cl2, and bromine will exist as Br2, and iodine will exist as I2, and fluorine, it will exist as F2, right? So fluorine, chlorine, bromine, iodine, astatine, and then we have another one, tennessine. So this is group 7, but we need to mainly focus on the first four. So we hardly go up to iodine, right? As diatomic, so this is what it is meant by diatomic. So their molecule will be made of two atoms covalently bonded together, right? So now let's take a look at their general trends. So increasing density, yes. So as we move down the group, the metals, they gradually change from gases. So the first two elements, they exist as as a gas at room temperature. Bromine is a low boiling liquid, and the rest of them, they are solids, right? Iodine and astatine, they are solids. So as you can see that this shift from gas to solid, so it means that the density is increasing because the intermolecular forces between these molecules, they increase, which force them to join together and come closer to each other, and change their state from gas to liquid and then liquid to solid. So the density also increases because more and more mass is being confined in a smaller area so decreasing density, decreasing reactivity. Yeah, so I've explained it in our previous topic as well, that as we go down the group, so their reactivity, the reactivity of non-metals or reactivity of group 7 halogens, it decreases because remember that non-metals, they react by gaining electrons, right? So they react by gaining electrons. Since since the atoms, they get bigger as we move down the group. So fluorine, we will have two shells. Chlorine, we have 1, 2, 3. Bromine, we have 1, 2, 3, 4. Iodine, 1, 2, 3, 4, 5, because it is impeded 5. Astatine, we will have 6, right? So you can see that the atom is getting bigger and bigger as we move down the group. So the protons in the nucleus, they are unable to attract, to pull electrons towards themselves. So their ability of gaining electron, it decreases, and that is the reason that their reactivity decreases, right? Remember that due to the shielding effect and bigger atomic radius. So I hope this is clear. Now we move on to the second topic, which is state the appearance of the halogens at RTP as, yeah, so this is a memory-based question. So, and the information is given below. We don't have to write anything else. So chlorine gas. So you should remember that it is a pale yellow green gas. So this is how they will be asking questions like what will be the appearance of chlorine? That's it, right? And 1 mark, it will be a 1 mark question and you will have to answer. It is a pale yellow green gas. That's it, you know. So then bromine, it is a red brown liquid, and iodine, it is a gray black solid. So in this topic, you need to remember the color. So it's yellow, pale yellow green gas, right? And then and yeah, and you see it has two parts. So color and the state at room temperature, right? So yeah, and then we have red brown. So I think we can choose this one. Yeah, so it is a red brown liquid, and iodine, it is a gray black solid, right? So gas, liquid, and solid, and these are the colors. So yeah, and you have to memorize this. You need to remember this. So now next question is like topic is topic number 3. Describe and explain the displacement reactions of halogens with other halide ions, right? So this is something that where students make mistakes, a lot of mistakes, and they struggle understanding this. So let me explain. So remember that as we move down the group, which we just learned, their reactivity decreases, right? So F2 will be more reactive than Cl2, and Cl2 will be more reactive than bromine, and bromine will be more reactive than iodine, right? And iodine will be more reactive than astatine, right? So uh, now the more reactive can displace the less reactive, right? So remember that more reactive uh, can displace less reactive, right? So this is you need to understand, right? So now uh, I'm going to give you some equations. For example, Cl2 chlorine gas, when it reacts with sodium bromide, NaBr, that's a salt. So since chlorine is more reactive, chlorine is higher in the on the periodic table in as compared to chlorine is higher than bromine, so it will be more reactive, right? So it will be able to displace it. So these are basically single displacement reactions. So bromine will be kicked out of the salt, and chlorine will take its place. So it will be sodium chloride, right? And if I have to balance this equation, so I'll have to put 2 here, and I'll have to put 2 here. Now the equation is balanced, right? But if it is like this, so Br2 bromine reacting with sodium chloride, what will happen? No reaction, right? So there will be no reaction because bromine is less reactive. It is less powerful than chlorine because bromine is lower in the periodic table as compared to chlorine. So that is why it will not be able to kick chlorine out of the salt, right? So this is how you need to develop your understanding. So fluorine can displace all of them. Chlorine can displace bromine, iodine, and astatine, but not fluorine. And bromine can displace iodine and astatine, and it cannot displace chlorine and fluorine. And iodine, it can displace only astatine, and it cannot displace bromine, chlorine, and fluorine. And astatine, the poor guy, the least reactive, it cannot displace any of the yeah, it can displace technically the another one, tennessine. I don't remember the symbol of tennessine at the moment, but yeah, there's another one at the bottom, and that will be the least reactive, so it's better I should confirm the symbol. It is TS, right? So yeah, so TS, that is tennessine. So that is the least reactive element among halogens like group 7, and it will not be it will be displaced by all the halogens, and it will not be able to displace a single element, right? A single halogen. So this is how you have to develop your understanding. And yeah, so another topic that is like related to this, so you have to observe the experiment by the color change, right? So for example, like when this reaction takes place, right? So and the reaction will the beaker in which this reaction is taking place, as soon as bromine appears, the liquid, brown orange liquid, so the flask, the beaker will turn orange. Remember that, right? So they may give you a question that we added chlorine into sodium bromide, and you know the beaker turned orange. Explain, that why are we seeing, this orange brown color, right? So you will have to say that because of the, production of bromine, about a single displacement reaction, since chlorine was more reactive than bromine. So it displaced bromine, and now we have bromine in a liquid in a pure state. So that is why it turned brown orange, right? So yeah, and if I have a reaction, like for example Cl2 plus sodium iodide, so since chlorine is more reactive than iodine, so iodide will be kicked out, chlorine will displace iodine, and another product will be NaCl, right? So yeah, so now, in this case, the beaker will turn brown because iodine has a brown color, right? So, like iodine solution, this is going to be an iodine solution. So, in a solution, iodine has a brown color. Remember that. That is very, very important, right? And these are displacement reactions. So, I hope this is clear. Now, we move on to the last topic, which says that predict the properties of other elements in group 7 given information about the elements. So the same thing. So, they will ask you that, which one is the least reactive element. So you have to look at the periodic table that will be printed on your question paper at the end of it. So you can say that you will. So you just need to remember the trend, right? So their density is increasing, down the group, right? And their melting points and boiling points, they are also increasing because they are changing from gases to liquids and then liquids to solids as we are going down the group. Let me just write the elements again: fluorine, chlorine, bromine, iodine, astatine, and tennessine, right? So tennessine will have the highest melting and boiling point, but we, stick to, yeah, and it will be least reactive. So reactivity decreases, right, down the group. And so fluorine will be the most reactive, right? Most reactive, and tennessine will be the least reactive. So you need to develop this understanding. You need to remember, you need to keep these points in mind. And, let me see if I can find any question from, related to this topic from the past papers so that I can, yeah, okay. So let me just add this question here, which says that, yeah, so this question, it says that potassium iodide is an ionic compound because it is a metal and a non-metal. Remember ionic bonding, right? So aqueous chlorine reacts with aqueous potassium iodide, complete the symbol equation. So yeah, so you see, and now you have to look at the periodic table. So chlorine is more reactive than iodine, so it will be kicked out. So iodine will be the byproduct, like I2, right? And now we need to balance it as well because it has 2 marks. So if you just write the product and don't balance it, you will only get 1. Remember that. So now I have to, yeah, now the equation is balanced. So the next question is choose from the list the name of this type of reaction. So yeah, that is the displacement reaction, right? Single displacement. So state the color of chlorine gas at room temperature and pressure. Again, this is it's a memory-based question. We learned that it is pale green. Yeah, pale yellow green, right? So you can answer by saying yellow green, yellow or green. Yep. So this is how they ask questions. Now let me find okay another question which may be really which will be related to this last topic, like predict the properties of other elements. So blah blah blah. I think that's it. Yeah. So when we will be covering, separately the past papers related to questions related to this topic. So, I will cover all the, topics, all the, like, most of the types of questions in that lecture, right? So we can conclude the lesson here. And don't forget to like, subscribe, and share. And yeah, you can join my community on school.com with the name of High School Chemistry. And the link is given below in the description. So this will be all for today. I'll see you in the next one. Take care. Goodbye.